So what if you're given a problem like this? So water flows into a tank at the rate of dW dt equals 1/75 of 600 plus 20t minus t squared, where dW dt is measured in gallons per hour and t is measured in hours. So you are given a rate and you have water flowing into the tank at that rate. And then they give you some other information. Let's say that at time 0, there are 150 gallons in the tank. With this information, you can actually determine all kinds of things. So we actually have a start amount. So there are 150 gallons in the tank, and someone says, how many gallons when t equals 24? Well, using our fundamental theorem, again, I'm going to write it down as f of a plus the integral from a to b of f prime of x dx equals f of b. Start plus net change equals final. For this one, it gave us a start amount of 150 gallons. And that happened at time 0. So 0 goes here. They wanted to know, well, how many gallons do you have when t equals 24? So I want the net change from 0 to 24 of my function my rate dt. And this would give me the f of 24, which in this case would be a w of 24. It would be how many gallons are actually in the tank at time 24. Well, what if you actually said at t equals 10, there were 300 gallons in the tank. So you have a different time, a different start amount. And they wanted to know, well, how many gallons were there at t equals 3? It should make sense to you that you should get a number that's smaller than 300 gallons because it says water's flowing into the tank. So at time 10 there are 300 gallons. We would be working backwards to figure out at time 3. But I'm going to just write my integral like this. So at time 10 there are 300. So 300 is my start amount. But that goes right here with this 10. I'm getting the net change from 10 to 3 of my dW dt, or I could just say the 1/75 times 600 plus 20t minus t squared dt. Well, this turns out to actually be the subtraction I need, because if you look at my limits of integration, it's from 10 to 3. Normally when we integrate, we would integrate from 3 to 10 for this function, and from 3 to 10 this function is positive, but when I switch that 300 minus 3 to 10, I'm going to be subtracting out just like I should, so I will end up with a smaller number than what I started with. So I always have students ask me, does it matter where your limits of integration are? And the answer is absolutely yes, it matters. This has to match with this, always. And then you have to actually read the problem and make sure it makes sense. If they tell you that water is flowing out of a tank and they're giving you some positive value saying that, hey, this is the rate of change of the water, and it's positive, if you don't subtract, it's not going to make a lot of sense. So you should always look at your final answer. But this and this should always go together on your initial problem when you start. So if this is the starting amount, this would be the starting time. And because I have my start plus my net change from this time to this time will give me how much I have at the final time. But always read your question, read your answer, make sure they make sense together.